All right, today we're cracking open one of the most important pieces of the modern web, authentication. We're going to get right into mastering the JSON Web Token, or JWT. You know, that magic that lets websites actually remember who you are from one moment to the next.
Think about it. You log into a site, you click on a link, you hit refresh, and somehow it still knows it's you. How in the world does that work? Especially when the servers behind the scenes are built to be forgetful, to treat every single request like it's from a total stranger.
Well, it all comes down to a huge challenge in modern web design. Servers are stateless. They don't keep a running list of who's logged in. That's just not efficient, and it definitely doesn't scale. So if the server has no memory of you, you need some way to reintroduce yourself every single time.
And that's exactly where the JWT comes in. It's a secure, self-contained little packet of information. Honestly, the best way to think about it is like a digital VIP pass. It has everything the server needs to know who you are and what you're allowed to do, all without having to check back with the database.
Now, this VIP pass has a very specific structure. It's 3 parts, all separated by dots. The first part, that's the header. This is just some basic metadata. It tells the server, hey, this is a JWT, and most importantly, which fancy algorithm was used to sign and secure it.
The second part is the payload, and this is the good stuff. This is the heart of the token. It contains what we call claims, which is just data about you, the user. Things like your user ID, maybe your role, like admin, and crucially, an expiration date. This is the part of the pass that says who you are.
And finally, we have the most critical piece of all, the signature. The server takes the header, the payload, and a secret key that only it knows, and smushes them all together to create this unique signature. It's the tamper-proof seal. If a hacker tries to change the payload, say to upgrade themselves to an admin, the signature won't match anymore. And boom, the server rejects the token instantly.
So you take those 3 parts, you encode them, and you join them with dots. What you get is this long, compact string of text. That's your complete VIP pass. And because it's just text, you can send it anywhere. In an HTTP header, in a URL, it's incredibly portable.
So, why do we bother with all this? Well, the benefits are huge for modern apps. It makes that stateless authentication possible, which is absolutely key for scaling up. It's a lifesaver in microservice architectures, where you might have dozens of different services that all need to know who you are without sharing some central login database. Plus, it's a great secure way to share user info across different websites or domains.
Okay, so that's the theory. But let's see how this all plays out in the real world. We're going to follow the complete life story of a token, right from the moment you log in.
The whole process is really a 5-step dance. You log in, the server makes a token, your browser saves it, your browser sends it back with every request, and the server checks it every time. Let's walk through it.
Okay, step 1. No surprise here. It all kicks off at the login screen. You type in your username and password, you hit submit. This is the one and only time your actual secret credentials get sent over the wire.
The server gets those credentials, checks them against its records, and if everything matches up, it says, okay, you're legit. Then it gets to work, generating that 3-part signed JWT we just talked about, packing your user ID and an expiration time right into the payload.
Then the server sends this brand new token right back to your browser. Now it's the browser's job to catch that token and store it somewhere safe. And we're going to talk a lot more about where it stores it in a minute, because getting that wrong is a huge security risk.
Now for the cool part. For every single thing you do after logging in, loading your profile, posting a comment, anything, your browser automatically grabs that token it's stored and attaches it to the request. It puts it in a special spot called the authorization header. It's basically flashing that VIP pass at the bouncer every time it goes anywhere.
So when the server gets that request, it doesn't need to look you up in a database. It just pulls out the token, checks the signature to make sure it's legit, and checks the expiration date to make sure it's still valid. If everything looks good, you're in. If not, you get a permission denied. And this happens on every single request.
Okay, but wait a minute. What happens when that VIP pass expires? Do you get kicked out and have to log in all over again? Not quite, and this brings us to a much more clever and much more secure setup that uses 2 different kinds of tokens.
This is where we see a really smart separation of jobs. You've got your access token. Think of this as your ticket to a single concert. Its only job is to get you into protected areas, and it expires super fast, like in 5 or 15 minutes. Then you have the refresh token. This is more like your season pass. It lasts for a long time, days, even weeks. It's stored way more securely, and its only job is to get you a new access token when your old one expires. This system drastically cuts down the risk if an access token ever gets stolen. And just to round things out, you might sometimes see a third type of token, the ID token. Now this one's different. It's not about what you're allowed to do, which is authorization. It's about proving who you are. That's authentication. It's mainly used to share your identity info, like your name and email, with an application.
Okay, let's pause, because what we're about to talk about is probably the most important part of this whole thing. Using these tokens is powerful, but if you do it insecurely, it can be an absolute disaster. So let's run through the critical do's and don'ts.
Here is rule number 1, and you've got to burn this into your brain. The JWT payload is encoded, not encrypted. Anyone can easily copy that text, paste it into a decoder online, and read exactly what's inside. That means you should never, ever put sensitive information in there. No passwords, no credit card numbers, no secrets. Keep it minimal. A user ID is usually all you need.
This brings us back to where you store that super valuable, long-lived refresh token. The wrong way, and you see this all the time, is putting it in local storage. That's a huge mistake because any malicious script running on the page can just reach in and steal it. The correct secure way is to store it in a special kind of cookie, an HTTP-only cookie. That HTTP-only flag is a command to the browser saying, hey, don't let any JavaScript touch this. It walls it off and protects it from a whole class of attacks.
So we've waded through a lot of technical details here. Let's just pull back for a second and focus on the big picture. Why does getting all of this right matter so much?
It really boils down to this simple, kind of scary truth. In this stateless world, that token is your identity. If an attacker steals it, they are you. They can do anything you can do until that token expires. The power and scalability of JWTs come with a huge responsibility. The security of your entire application rests on how you handle that token on every single request.
So I'll just leave you with this question to think about for your own projects. That little string of text holds the keys to your user's digital kingdom. Are you absolutely certain that it's secure?